Lesson 44, Finding Slope Using the Slope Formula. The best part about today's lesson is that we've already talked about the slope formula in a previous lesson, because I think it's best to just go ahead and give it to you because it's a surefire way to figure out the slope when you're dealing with 2 points. And so today is basically going to be a review and a practice of what you already know. It says slope is a measure of the steepness of a line. The slope m of a line containing points x1, y1, and x2, y2 is, and they give us this nice formula. Where's my pen? Why am I not working? Hello. Alright, fine. Alright. So, the formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is the change in y over the change in x. We've always talked about slope being rise over run. And when you're looking at the coordinate plane, it's exactly rise over run, and now we talk about it as x and y, because rise is up and down. Well, up and down, this is my y-axis. I run from left to right, and that's my x-axis. So that's where we get that from. So it wants to determine the slope of the line that contain the given points. So they're giving me, on each of these, they're giving me x sub 1, y sub 1, and x sub 2, y sub 2. Okay? So when we do this, I'm going to use my formula, which I would love to be able to write with my pen. So I'm going to use my formula. M equals y sub 2 minus y sub 1. And it's important that you write these as subscripts and not as exponents, because that's something very common that we do. And then some of us get confused and we think we need to square something, and we do not. Okay? This just means the first x and the first y and the second y. That's all that it means. Okay? So please don't be confused by that. So, my y sub 2 is what I'm going to start with. Y sub 2 is 11. And as I plug them in, I'm going to scratch them out. So, y sub 2 is 11. I'm going to put a line through that, and I'm going to plug it in over here. So, instead of y sub 2, I'm going to put 11. Minus, instead of y sub 1, I'm going to put 7. It's very important that you label your points and that you mark them off as you go to eliminate any errors that you may have. X sub 2 is 9, so I'm going to plug in 9, minus x sub 1 is 5, so I put 5. So now all I have to do is the math. 11 minus 7 is 4, 9 minus 5 is 4, so the slope of this line is 1, or 1 over 1, okay? That's my final answer. I would like for you to try and do B and C on your own paper, so please pause the video and work on those two. Okay, and we're going to do D together. Okay, so again, we're going to start by labeling x sub 1, y sub 1, x sub 2, y sub 2, and it's always x sub 1, y sub 1, x sub 2, y sub, I put 2, because this is point 1. This is my first point. It doesn't really matter which way you put it, but it is important that x and y are always together, and that your x1 goes with your x coordinate, your y1 goes with your y coordinate, and then your x sub 2, y sub 2, that's your other point that we're talking about. So we always have x with x and y with y, but the sub 1 and sub 2 must always be together for the same point. So I'm going to cheat and use the formula that I already have written up here to plug into. You should always rewrite the formula whenever you're doing one of these problems. I will never, ever, ever accept for you to just plug it in without writing the formula. You need to write the formula so you do not make a mistake. So y sub 2 is negative 8. So I'm going to plug that in for y sub 2. Minus y sub 1, which is 2, over x sub 2, which is 2, minus x sub 1, which is negative 3. This is another reason why it's very important to plug into the formula, because we sometimes forget about a negative whenever our coordinate has a negative and there's a negative in the problem. Okay, we have to make sure that we're very careful about that. So on top we have negative 8 minus 2 gives me a negative 10 over. Then I have a double negative, which I hope we all know at this point gives us a positive. So 2 plus 3 is 5, and negative 10 divided by 5 gives me a slope of negative 2, and that's my final answer. Determine the slope of the line that contains the given points. Whenever you do this, we have x and y. We should always know that this is one coordinate, this is another coordinate, and this is another coordinate. Okay? So whenever I have this, I always start by taking the first one and I call this x sub 1, y sub 1, and x sub 2, y sub 2. Okay? So once I'm here, I can find the slope. So that's what I would like for you to do on your own paper. Please pause and find the slope at this time. So our formula is what we should always start with to find the slope of a line, which is always m equals y sub 2 minus, that looks not like a minus sign, but pretend like it does, y sub 1 over x sub 2 minus x sub 1. So, using the points that I chose, you could have chose any 2 points and you could have labeled them any way that you want to. Okay? So, instead of y sub 2, I'm going to put in negative 3 minus y sub 1, which is a positive 3, over x sub 2, which is 1, minus x sub 1, which is negative 2. So whenever I do this, on top I have negative 3 minus 3 gives me a negative 6, and then minus a negative 2 gives me a positive here, so I have 1 plus 2, which gives me 3, and a slope equal, that's an equal sign, to negative 2. Final answer. It says determine the slope of the given line. And they've given us, once again, a graph here. They've given us 2 to work with. And they tell us the coordinates. This point's not supposed to be there, so please ignore it. Okay? So I'm going to say that this is x sub 1, y sub 1, and x sub 2, y sub 2, and I usually always label them from left to right because that's the way that we read a graph, is from left to right. So I just usually start with the first one I see on the left and I label it and then go to the next one. Once again, you could put them in any order, you're still going to get the same answer. So I'm going to write my formula, which is m equals, that's a y, sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my y sub 2 is 7 minus my y sub 1 is 4 over my x sub 2 is negative 2 minus my x sub 1 is negative 4. So whenever I do this math, I have 7 minus 4, which is 3, over negative 2 minus the negative here gives me a positive. So negative 2 plus 4 is going to give me 2. And this is how I leave my slope. I don't want to have a decimal for slope because slope is always rise over run. So I want to see it in that fraction form. On the others, we did talk about going ahead, if it was, say, 4 over 2, we would reduce it to 2, because a 2 is always understood over 1, so we can very quickly get it back to that fraction. But we don't want to have to deal with changing a decimal back to a fraction, so whenever we find slope, we leave it as an improper fraction if it doesn't divide evenly. I would like for you to do B on your own paper at this time. On B, once again, we start by writing our equation. m equals y sub 2 minus y sub 1 over x sub 2, that's 2, minus x sub 1. So I'm going to label these starting from left to right. I have x sub 1, y sub 1, and x sub 2, y sub 2. So instead of y sub 2, I'm going to plug in this negative 3 minus y sub 1, which is 1, over x sub 2, which is negative 4, minus x sub 1, which is negative 7. So double negatives here is going to give me a positive, something we quickly see. And I have negative 3 minus 1, which is negative 4, over. I have negative 4 plus 7 is going to give me a positive 3. So my final answer, I'm going to write it so you can actually read it, is negative 4 thirds. And once again, I'm going to leave it as that fraction, not going to change it to a mixed number or a decimal. On problems or lines like C and D, these are very special types of slope with our lines here. You can see very quickly that this line is horizontal, and all horizontal lines have the exact same slope, and we're going to figure it out here so that we can remember. We always start by writing our formula, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and I'm going to label x sub 1, y sub 1, so I know what I'm plugging in, and x sub 2, y sub 2. So instead of y sub 2, I'm going to plug in 4, minus y sub 1, which is also 4, over x sub 2, which is 6, minus x sub 1, which is negative 6. So I have I have 4 minus 4, which is going to give me a 0. And then 6 minus a negative gives me a positive 6. So 6 plus 6 gives me 12. And 0 divided by 12 is 0. Okay? You can see, looking at this horizontal line, it doesn't rise or fall. Okay? It stays the same the whole time. So anytime we see a horizontal line, it is an understood slope of 0. Please, please, please put that in your notes. It's very important that you remember it. It'll save you lots of time. On D, just like a horizontal line, there is one specific slope for all vertical lines. So we'll work that out here together. I have x sub 1, y sub 1, and x sub 2, whoops, that's an x, sub 2, y sub 2. My formula is m equals y sub 1, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So instead of y sub 2, I'm going to plug in my negative 5. So I have negative 5 minus y sub 1, which is 1, over x sub 2, which is 7, minus x sub 1, which is 7. So on top, I have negative 5 minus 1 gives me a negative 6, and 7 minus 7 gives me 0. Well, negative 6 divided by 0, it's probably unlikely that you have your calculator in front of you, but if you do, go ahead and plug that in and see what it tells you. Even if you are at home and you have your phone, plug that in and see what it tells you. It should tell you that you get an error, because we don't know how to divide by 0. So vertical lines are all known to have an undefined slope. So the slope of any vertical line is undefined. Alright, so a rate of change is a ratio that compares the change in one quantity with the change in another. So it says a biologist is trying to determine the top speed of a cheetah. The second hand was at 14 seconds when he began timing, and at 51 seconds when the cheetah had run 1,184 meters. what was the speed of the cheetah in meters per second? So, first of all, some things that we need to think about. Meters per second. How would I write that as a fraction? Meters per second. I hope that you're thinking it would be meters per second, because it should be. That means meters are going to be on top. So I'm going to have 2 points, okay? At 14 seconds, how far had the cheetah gone? It's when it says that's when the cheetah on the second the second hand was at 14 seconds when he began timing. Okay, so how far has the cheetah gone? Nowhere, right? So it's at 0 at that point. Then it was at 51 seconds. 51 seconds, and the cheetah had traveled 1,184 meters. Okay, this is my x and my y. You should remember that the change in y over the change in x is my slope, which is what I'm finding here. Okay, that's an equal sign, not a less than sign. So you can see that my meters are my y value, which is how I've written this. I've written this in the form of x and y, right? So this is going to be my x sub 1, y sub 1. This is going to be my x sub 2, y sub 2. And what I would like is for you on your own paper to find the speed of the cheetah in meters per second. I hope that you've taken good notes, and I'll see you in class tomorrow.